Okay. Hello everyone, and welcome to the Better Build Prep webinar. My name is Adinda. I'm a customer support at AMIS. Thanks everybody for joining us. We've noticed that there's a mix of SLS and MJF users today, so we think that that will probably create an interesting discussion afterwards. Uh, Today, my colleague Chris is going to demo the software and its latest features. If during the session you have any questions, then please feel free to add them in the chat. Down below, you'll see a little icon with the Q&A on there, and there you can ask the questions. And so we'll wrap up the demo with the Q&A, and we'll also provide the presentation afterwards. So without further ado, I'd like to pass the word to Chris.
Yes, thank you, Adinda, for this introduction. Um, as she indicated, I am indeed Chris. I think I know quite a few people amongst you, but I'm also very glad to welcome a couple of new interested people, new users, perhaps. So it's also in that regard a nice mix. Now, some of you have maybe already been present in previous webinars. This time I decided, or we decided, to actually focus even more on the demo so that you more get a feel of AMIS Pro, of how it works. But nevertheless, a couple of slides as an introduction, of course, to what it is that we're doing and what AMIS is about. But we'll keep it very limited. Anyway, we're available, as Adina indicated, for your Q&A, either just after the presentation or else anytime that suits you. So here we go. First of all, about AMIS, of course, well, what do we try to do? I think we've set off on this adventure a bit more than 2 years ago now, with the main aim really to bring a change in build preparation for a few technologies only. Few technologies meaning initially focusing on all jetting technologies, so including MJF, that is, and SLS. We wanted it to be an off-cloud editor because that's what most people actually use. And we wanted it to have a new vision on how to look at build preparation. A new vision and a new approach, let's say. I think of course, you can always look at higher speed and better user interface, etc. But I think what we've mainly tried to do is actually have a new look at it. Really focusing on these technologies allowed us to downscale the focus and to really go for a number of features that are relevant for you. So more in detail, what will we do and what will we be talking about today is a bit about this approach that we're trying to follow. The newest features in AMIS Pro in the version 3.02 that is nowadays, and that is mainly, again, as always, I would say, looking at improved cost per part. We also have a secret pre-announcement, especially for you. Soon, in a couple of weeks, you will hear all about it, but we couldn't stay silent, so that will also follow. The main part will be the demo, the pricing we will mention, and of course, we hope to see a lot of questions in the Q&A session. So a bit more on this approach, and I think it started from talking to our first users or people who are in the business anyway, the realization that there is no one strategy, there is no one recipe. A lot of people have their own way of doing their build preparation. That's, of course, related to the fact that there is a couple of possibilities in software, lots of different machines, etc. But still, it's also a different way of working with it. And I will show a couple of those things in the demo as well. People just have their preferences of going about it. And in that sense, AMIS is just a means to an end. It needs to allow you to work the way you want to work. And that's, I think, our approach. That's how we've seen this. Also, and that's more from a technical point of view, there is no one algorithm, I would say. There is no one way that the packing can always be good for any technology, for any type of parts. And I'm saying it in the next bullet point. It's a complex matter. It depends on the machine, on the material, on the parts, on the size of the parts, etc. So that means the system needs to allow some, yeah, for the user to try and find the best way that fits him, her, and or the parts in the build box at that moment. So it's about tools that facilitate your work. And I think one thing that is not on the slide, but that most people that are a user already know, these tools and the priorities of these tools, basically they're just following what you, how you guide us, what you tell us. So that's an extra reason to put it in the Q&A, but also to contact us and say like, okay, I think this would be useful, this could improve, there we could still move forward. So that's always welcome. But that's how we see the goal of our organization, or the path we set onto with preparing this better build prep. Now, why do we do it? What needs to be the goal of this better build prep? Let's say, of course, you want to put in more parts, preferably, because that's basically your cost per part. You want to have less risk of broken parts, parts that get lost in the post processing, etc., etc. You want support, of course. You want, as a software user, you want to have support, and so we want to foresee the scalable and scaling support together with you, our users. And you want to spend less time on nesting, because basically it's something that needs to be done, but you can spend hours on it, or you can just do it in minutes. And you want the user experience that is at least reasonable, let's say, allowing you to work quickly, easily, and the way you like to work. And all that is related to, and I mentioned it already, to cost per part. Because basically, if you have more parts broken in your batch, obviously that's taking up your cost per part, and that's related to putting more parts in the batch, which might be a good thing, and which of course brings you a lower cost per part. But if on the other hand the risks increase, then it will again increase your cost per part. So it's finding that level between quantity, quality, that you need to be able to play with when looking into build preparation in general. And so that's our focus. So anything that helps us with that focus, we believe also helps you. And so that's again why we want to hear it from you. Now, in the version 3.0.2, that's actually, the 3.0.1 was only a month and a half ago or something. So we're moving fast. We're bringing out new features quickly. And in this just bit over a month, we added, for example, the automatic collision checks. Automatic meaning they can be automatic. You can choose that in the preferences. I will demonstrate that later, or you can do it manually as you wish. You have a lot more options when it comes to the part list output, also to output it as a JSON file, which means you can put in a lot more data, which you can reuse in your automation or in your up and downstream workflow, your MES systems, etc. And that touches already a bit on automation, as something I will be mentioning soon. You can now duplicate parts. You can do SLI exports, CLI exports, which is of course needed for a couple of SLS machines, of course. There is an improved output, which maybe you won't notice, because as it says there also in the back end, quite a few changes have been made. Some of them very noticeable, other a bit less. But for example, on the output, you will see that basically the user interface is much easier. And yeah, that again makes hopefully your life a bit easier in that sense. So that's what happened recently. And then was an, I would say, exclusive announcement, because nobody else has been informed yet. On February 16th, so in 2 weeks and a half from now, we will launch our AMIS runtime. launch. I should say officially launch, because actually we already have a couple of users who are currently running the system, or currently also doing tests with that system. And it's, I believe, no, it's not just I believe, I know it's actually unique. There is no such system available at the moment, allowing you to do real scripting on your build preparation and to fully automate and link your build preparation to your entire workflow. So more details on that will follow. You can all read a bit of the promotion that's here on the slide. More details will follow, and definitely for a couple of users amongst you, this will be highly interesting to actually, well, again, move forward on better nesting, on more automated nesting. So we're definitely also looking forward to that one. By the way, this is fully operational. It comes already with examples, and it comes with a full documentation on the runtime. So once it's out there, definitely, if you're interested, give us a sign. We'll get back on that to you. So I promised to keep it short. I tried to keep it short, so we can now move on to the demo, in which I should say, I think that's also very important. A lot of the examples are actually examples that we got from our users. So things they either struggled with or thought like, hey, I found a new approach for this, or things like that. So also those stories are very welcome, because we can immediately reuse them in our demos. So here we go, I would say, with batch number 1. It's an ESP396, although you might say there is actually a no build zone which is missing there in the printing in the batch area. So for that, it shouldn't be that difficult, and it's just the same amount of clicks. You can either in the setup start with a new batch with the same dimensions, of course, or you can just open a batch, or rather a printer, which is already predefined. So here I've got my P396 predefined with actually this no build zone in there already. Now I've made this a hollow part, because then of course it will have much less impact on the density, on the nesting density. So it's in there, but it's actually a hollow part, so that it doesn't influence, well, basically our nesting procedures. And then, as most of you know, in AMIS Pro, you go normally from left to right with setup and then parts, which doesn't mean you have to. You can also, of course, go back at any time. But let's put in one specific part there. I'm just starting with one part for now, because it was a question I got only yesterday from, I think, one of you who is in the meeting or in the webinar right now. But more importantly, a question we get quite often is about this import. And then the question is, of course, hey, wait, don't you do a check and a healing on import? Some people are used to software whereby you have a lot of parameters and things you can set actually about the import and repairing the things. And then basically the answer is like, well, you normally don't need it anymore. And we do a check upon import on the file integrity, and we do repair it on a lot of things which are being checked and repaired at the import phase immediately. So basically that means that we're still looking. We did have a few parts that were sent to us by a couple of users that said like, okay, there's a problem importing this part, and seems to be okay. So what's wrong there? So we adapted that, and but that happened only once or twice. So basically, if you would still have parts that would not be opened here, we would be very glad to know. But we repeat that request every time, and we never get any parts that are not properly imported. So yes, we do file checks. Yes, we do file repair, but it's automated and it's done upon import. I think that's a important thing to know already. And then the question I just got yesterday was related to parts that actually somebody wanted to to do a shelling on the part, but he didn't want to redo that shelling every time upon import. So he thought like, okay, is there no way of saving the part? And actually, yes, there is. So let's first this part. Hang on, I will double click. So we're in the part view now, and then I click the section view so that I can go through the part. And then you see, of course, that it's at this moment not shelled yet. It's not hollow. So let's put a shell in here, for example. 3 millimeters. For people who perhaps are new with AMIS, you can also add a lattice structure if you want, which you can also change here the dimensions of the lattice. But for now, let's just add a shell in this one. So there you go. That's the shell part. And so, well, the question was like, okay, can't I save that part somehow? Well, actually you can. If you just nest the part and then, well, you do have to remember to delete this one. You output the part. And now I've already, oh, this is a TIFF. I will change that in the settings and make that a mesh 3MF file. There we go. So there we got the output part. And if I now reopen just any printer, but I will go back again to the 396, I can just import that one part, which I think I saved on my desktop. Okay, I keep on forgetting that. Then it's hopefully here. Did somebody see where I put it? I don't. No, this is another shell part which I used. But anyway, the part that we exported is saved as a 3MF file, which can then be re-imported and is saved as such, of course, as a shell part for the future use. So that makes things quite a bit easier. Now, I already noticed, and maybe you didn't see it, on the output, things got quite a bit easier. Meaning, it used to be possible here to click on the output for a 3MF, an output for an STL file, etc., etc. Now we just connected the printer with the output type, meaning that once in your printer, you will configure actually what your output type will be. So you don't have to redesign that each time. And as that printer has been selected, it will automatically, when you output it, it will automatically select that preference in here. So here for the EOS, apparently I put in that it should be saved as a TIFF file, so it will automatically indicate that. Nevertheless, you can still overrule that. You can say here settings and then change it here so that you overrule the normal printer settings as such. So that's a bit a new view for many of you. But it makes it easier because there's no changing of settings or no selection needed anymore. You can just go up. Now you also see that I created here a nice collision, which, by the way, is still the only way you can actually have a collision because the nesting algorithm doesn't allow for collisions to happen. But of course, if you have a full build box with lots of parts in it and you move one a bit around, it is, of course, possible that you create a collision yourself. Now you can do a collision check. Here's the button, and so indeed, yes, a collision was noticed. But we also made it possible to do that automatically, as I indicated before. So here in your settings, you now have this extra output, which you can put on or not, which enables the collision checking at every output. So basically that means you're safe. If you put that on, you're safe because automatically when you output something, it will first start with doing a check on the collisions. You can put it on or off as you wish, but please don't. Please remember to click the save button here below. Otherwise, it won't be seen. So that's already a couple of new features in there. Okay, let's move on perhaps to a next batch. I will discard this one. I will create a new batch and I will start adding some parts inside. And then, of course, I have to go back to my workflow. Here's my backlog. Let's put in something that is quite, well, seems to be a lot of demand at the moment for this. Some drone parts that I put in, and then actually it was also just a couple of days ago that a customer asked me like, okay, I want to rotate this part because it doesn't fit into the build box, but if I double click it to start rotating it, I don't see where it is anymore. I can't really know if I'm turning it correctly. Like, oh, let's try something like this. I have to go back, see in my batch, like, oh no, it's still not fitting. By the way, if you just nest once, you can see if it actually fits. No, it's still outside, so it means it doesn't fit. So he was struggling with, yeah, with this idea that you can't see how it actually rotates. Now, I think it's very important to realize, and it's also mentioned here in the settings, by the way, that you can rotate your parts also by using these shortcuts, Alt X, Y, Z. Most people put it at 15 degrees. So basically your part manipulation with each click will be 15 degrees in X, Y, or Z. Because obviously that works very quickly for your daily or normal rotations. However, in this case, I'm going to put it at 1 degree, and actually it does go quite fast, so there is not so much reason. So I go clicking Alt Z, and I just keep my. It's not like I click 15 times. I just keep it in, and then I rotate. By holding Shift at the same time, I will rotate in the other direction, and so you can immediately see if it will be fitting your build box. So if I now try to put it in, normally the part should fit in there. Good. So that's one part in, but obviously that's not enough yet. So let's continue building this specific batch, this specific build. And then quite often, of course, the difficulty is perhaps those wings, because you want to print as many as possible, but of course they take a lot of place, whereas the other parts are quite small and they easily would fit in. So you end up quite often with nesting densities with this type of parts, which are very low. So basically, there's a you want to try and put in more parts. Now let's start with these wings, and then I go again to parts so that I got my part details here. Um, and let's put in some more copies. Let's see if we can fit in 4 parts here. I first want to work on those because they're so tall, and I want to see what can I do to improve that. Okay, seems like I can get in 3 parts without any further movements. And I would like to, if possible, have 4 parts maybe. So let's see if we can get in more. Now there, we got 4 the same parts here. Of course, we work with, and that's an important distinction also in AMIS, of course. There is a big difference between more copies of the same part or a different part. First of all, because nesting different parts will cost a lot more time in the nesting. But also it works faster if you have more parts of more copies of the same part, just because it's easier working. But in this case, you see that of course maybe 1 or 2 more parts will fit if I would be able to change the direction of rotation of these parts. And let's leave those 3 as they are. But maybe another one will fit if I rotate the parts a bit. But of course, if I start rotating this one, they will all rotate. So that's not exactly what I was what I was looking for. And so I can rotate those, but that's not gonna help me in getting in more. So at that moment, I have to duplicate my parts. Now let's first maybe reduce this to 3. Voila, so that I have them all in here. And then I will duplicate this. There's my duplicate. And with that one, I again start working. Let's again take the top view just to have a bit of a view on what's happening there. And then again, I'm going to do this rotation now the other way around because I want to have it fitting in, hopefully like that. Any part that you win can help, of course, in lowering that CPP. Now I will perhaps also rotate a bit like this so that we have more chance of it fitting, and then nest it already and see if that works. Okay, there we go. Yes, it fits in 4 parts. Now, just also for the example, of course, I'm going to start increasing the quantities of the other parts. Let's put in 200 of those. And then again, I don't go clicking here. I use Alt N for next. Alt N is next part. So I'm now here. Alt N, next part. As you, by the way, can see here, and if I hover this button, you will also see that it says select the next part, Alt N, and with the others as well. If you want to do or if you don't remember the shortcut, then you can also always hover over the button to see what you need to do. Let's say 150 of those, Alt N, next part. Let's say 100 of those, I don't know, and then 150 of those. And this did maybe 50 parts, and this last one is the drone wing. So I've already entered the numbers of parts. Of course, there are more properties that you can actually influence here in the parts section. Of course, you can rotate also by typing here. But before, of course, we did it using the shortcuts. You can scale your parts. You can change the copies. You can also change some of the nesting properties. So the nesting gap, and later on we'll look at the nesting, of course. The nesting gap is something which is decided on a nesting basis, and the gap distance 4 here. But in some cases, you might want a higher nesting gap for specific parts, and then you can put it in here for specific parts. Now I leave it at 0, so it will anyway go for the gap distance which is mentioned in the nesting section. And I can allow rotations. So meaning that during the nesting, that part is, for example, allowed to rotate over the x-axis or z-axis or multiple axes. Also, if you click on one instance of a part, so one part specifically, I can take one outside the batch, for example, you will get its copy properties, meaning its position. Now, this part is outside of the build box, so I cannot lock its position. But when it's inside the build box, I can actually say like, okay, you stay there. I lock the position. It won't be changed anymore during the nesting operation. So, but anyway, we've set all the quantities, we've set the rotations. We think we're good here on this part. The shelling we demonstrated before. So let's see if we can get this one nested. So. And that's already two important things with AMIS Pro. First of all, nesting is pretty fast, so it's meant to iterate. It's not necessarily your final build that you're going to get out at the first try, but you're probably going to iterate. You're going to have a look at the result and then move forward from there. Like, okay, I'm now at 98% and it's still looking for solutions, and that's then the second important thing, cancel. There is, while iterating, no reason to wait for the 100% because we are still improving our build. We're checking, is this close to what we want, etc. Is this approximately what our aim is with this specific batch? Now, I'm a bit unlucky in a sense because I was hoping that my wings wouldn't fit anymore, but they did. However, what I wanted to show is that, and I will clear the batch again. I will just throw out everything again and re-nest again. If you want to make sure that certain parts are in first and that they're definitely in, and we already are sure that 4 of these wings fit, then actually we can use and now by using control here, so I can select multiple parts, I will give them a higher priority. So you see that there is a different sign, so the priority is higher. So the algorithm will first try to nest those before adding the other stuff. And so like that, I'm iterating. So okay, maybe the wings didn't fit in the first time, so I'm iterating and now trying this to get in the wings in for sure, so that we're okay on that side. If you would like, you could now also just really block those drone wings, meaning locking their positions as set. But for now, I will leave that. Here you see how many parts fitted inside your build box, so you can also make decisions based on that. If you say like, okay, only 66 of those. Let's try to minimize those quantities or minimize those and put in a bit more equal spreading there. So that's also a change you could be doing at this point. Now, another very important thing you will want to have a look at is your nesting density. If you click here on the density graph, you get this overview of what the density throughout your build box is looking like. Now, this looks like there are quite a few peaks still. Here below, you got 14%, which might be a bit high, depending also on the technology, depending on your settings. But in general, it's quite a straight line. I should also mention there that with some software, they take the average density over 2 millimeters or something. So it looks like there is much less peaks. We give you the density with every layer. So you really see every peak that is coming through. And then, of course, it's up to you to decide whether it's acceptable or not. But in the third example, we'll go a bit deeper into that nesting density and how to really go for it, how to really improve that. For here, I think that the most important thing is like, okay, the part rotation. How can you go about it? So there's a couple of ways. Prioritizing parts and the relevance or the use of that. And then on the rotation, by the way, we could also, of course, in our nesting still allow the Z-axis rotation, for example, apply to all parts. So now the algorithm has much more opportunity to go looking for alternative rotations of the parts, usually turned over that's turned over 90 degrees over the Z-axis. So the nesting will take a bit longer. And that's why quite often, if you're iterating through your way through it, quite often we see that the users will do this as the last step. So you're happy with the result already. You're close to what you want, but you want to check if maybe you can add a few more parts. Then that's maybe the right point where you say like, okay, I'm going to add more, or I'm going to allow rotations so that maybe a few more parts will fit inside the build box. One small detail that I didn't note yet. By using Shift and or your control button, so you can select your multiple parts at the same time, actually meaning you can also rotate them at the same time with the same idea, and usually over 15 or 30 degrees. In this case, I'm a bit freewheeling. And as long as I end up with nesting, I'm not afraid of any collisions whatsoever inside the nesting, because the collisions usually, if they come, they're normally because maybe you put some part in place, you lock them in place, and you created the collision by yourself. As indicated, by the way, my nesting does take longer because, of course, with allowing this Z rotation, I'm giving a lot more checks to be done or a lot more positions to be checked. So that takes a bit longer there. Okay, but we're already at an initial solution with now 7% density, which indeed, given the specific part, is probably the maximum we can get out of this type of batch. Good. A third example, and which will indeed take me another 6 or 7 minutes, which should allow you to still ask quite a few questions. Let's see what we're going to open next. Discard this one, because I want to zoom into something specific here. And that is indeed the multiple batch nesting, but not only that, mainly about these the densities and controlling the densities. This is just an example based on an idea by one of our users. He's having multiple batches, multiple printers to nest in there. What you see is that sometimes if you run it one by one, maybe all your bigger parts will end up in one batch, and then you're left with the smaller parts. And that's not a perfect division of your parts over different build boxes. So he basically built himself a printer. So he added a printer, which is then this one, triple size printer, and uses that just to get parts divided over different builds. And then what you normally get is that indeed the parts are quite well divided based on their size over the different build boxes. So you can start working with that. By the way, these parts here in the middle, these are, well, basically parts that we made by ourselves and which we locked in place. Here, lock position, so as to make that division so that no parts are actually in between two build boxes. That's also something which you can definitely use if you, for example, have SLS printers with multiple lasers, whereby you don't want to go over the stitching zone of the lasers. So then you can apply the same kind of trick. Okay, we're now ending up with 3 printers, but basically you can't really print that. Luckily, you can easily change your printer by clicking here, set printer, and putting that then to a normal sized printer. I will update the printer. So now we've got, I don't know if you can see this well, but this is my one printer. After which I lock all my parts, meaning all the parts inside the build box are now locked. I will clear all the other parts which are then left behind, and this is my first build box on which I can start working. Now, of course, this is not an ideal build. If you look at it, it's here a nesting density of 18.46. So that's too high. You just use this to divide your parts, but it's not your real work on the build box, let's say. For that, let's open a quite similar one here. There we go. Which is, and some of you might have seen that, it's a CAMSPEC file, meaning that's a file mainly generated by Phasio, a company we're also working together with on the workflow idea. Oh, I shouldn't import parts, which doesn't only contain the parts themselves, but also their rotations and their quantities. So I don't have to bother anymore about the part quantities. Now, if I go nesting this one, what I notice is that I'm actually working on a Forsoon, which was not the idea. So I'll switch it to my HP printer because that's what they were meant for. I will nest again and see what we get there. Okay. The parts inside are very similar to the ones I showed before. So again, we're ending up with a nesting density which is way too high. The most powerful thing here to work with is your max layer density. Basically, it will limit the density of each layer to this, in this example, 13%. Of course, you can put it higher or lower, but now let's try with the 13%, which is set in there. And there you will generate your solutions. Now, first of all, what we will see here on the density graph is that indeed it's nicely cut off around this 13%. So that's definitely what we want. On the other hand, what we also see is that the parts are quite a bit in the middle, which makes sense because basically if you want to check the layer density on a certain layer and move parts upwards as soon as that layer is full, as soon as that layer reaches the 13%, it means you have to start somewhere, and we start in the middle because that's the most logical place to start. So that's why they're quite often a bit together. So as such, yeah, this is printable because we got a nice gap distance, 4 millimeter, and we got a good density spreading. But if anyway, this is our maximum to fill up the batch, why would we not increase the gap distance? Because it will lead even to a neater batch and better print quality. So I will just do the same thing with a higher gap density, and your resulting nesting density will be still the same, but I got more spread out parts. Of course, what's ruining this batch is also the fact that these parts, yes, indeed, have not been shelled. And so they take a lot of bulk mass inside the nesting, so they increase your density a lot. And also in this case, it's really something you might want to shell, and it will give a totally different result than if we nest it. Of course, I know in many cases you're not allowed to do this by your customer, and there are agreements on what it should look like. But in this case, you will just notice that the it will come really to a better spreading of your parts. It will give a lot of more possibilities to the nesting algorithm to actually put your parts in as you want them. So our density looks good. Obviously, and again, that's the idea with the iteration. it's not like you wait for 10 minutes for your result and you hope that it's going to be good. You wait 20, 30 seconds for your result, you're going to check, and then you're maybe going to adapt things. So maybe you don't like the fact that this one is down below, touching the floor and at the same height as this other one. Okay, I'm going to pull it up. I'm going to lock its position. I'm also going to lock its position, the lock position of the other one. Sorry. And where's my number 3? Maybe I want to put that a bit up. Okay, fine. I'm going to lock its position. Of course, I created lots of collisions now, but I don't care because I'm just going to re-nest the whole thing. And by the way, okay, that's taking a few seconds. Well, I'm running this from my laptop, so this is not so much computing power which is behind. By the way, I wanted to say I locked a couple of parts. I can always clear the nest just to see, okay, how does it look? What did I lock? And is it actually not touching each other? So that's another collision check or check for yourself if there are no mistakes inside there. So clearing, nesting, locking, unlocking, locking the whole batch, locking individual parts are all options you have within AMIS. Right. Now, I did make myself this nice list of things I shouldn't forget to say. Undoubtedly, I forgot a few because there are more options within AMIS Pro. There are more possibilities. Oh yeah, for example, what I didn't show yet is this possibility to, where is it? Let's take a nice one, this impeller. I will just quickly make a duplicate out of that one. There it is. That's my duplicate. I will then do a boxing operation, which I can do square or freeform, which I can do automatic or manual in its size. I will execute the boxing, takes about a second. And there you got your box group. Oh, I was too quick. Sorry. Your box group, which is then gives you this as a result, which is you can fully change the dimensions of the holes, etc. And there's a couple of more things, but new in this version, so is here in the settings, the fact that you can enable the adjacent part list, that the output is now automatically checked on for collisions if you wanted to. That this one became much smaller and neater, that also on the output side you got less options. Well, basically you have more options, but it's more neatly packed, and you got the collision check in here as well. Right. I hope this gives rise to many questions, of course. But before we go into that, and please do keep on writing while I'm having 1 or 2 more slides now. Of course, we're working on our next version already, and we do think at this moment we are, well, we see it on the number of people that are actually using our software. We're there, but we want to move much further still. Next big thing coming up is the version 3.5 by the beginning of May that will be out, and that will, for a big part, focus on Boolean operations, meaning putting holes, putting labels, putting embossing, engraving of part numbers, etc. Automatically on your parts. And at this moment, we are doing some research on that, meaning we've already sent questionnaires to a couple of users asking like, hey, how do you do this? What's your parameters you would like to see or use for this or that Boolean operation? If you're a candidate to answer those questions, please let us know. We'll be glad to send you the questionnaire too. We will also allow aligning your parts to a face. You can immediately say like, okay, this part I want it rotated like that, downwards. We're going to do further density optimization, nesting optimization, and Z direction compensations for mainly then for the SLS users. So there's a lot in scope, which will be in there by May, and which will be released on the date foreseen. The pricing, it's on the website, no secrets there, $4.99 per license per month if you take the monthly license, and a 20% discount if you take the annual license. Of course, if you're interested in the automated results, the automated solutions, please do contact us. We got the prices for that as well. And of course, if you take multiple AMIS proceeds or take multi-year orders, we'll be glad to discuss that too. I would say over to you, meaning Adinda. Do we have any questions in our chats or in our Q&A?
Yes, we have a couple of lovely questions today. We got a question from Stephen asking, when exporting a part, is the current orientation also saved?
Thanks, colleagues, for warning me. Yes, indeed. When you output a file, that means, of course, that the parts or part within it is saved with that rotation from that moment. So yes, just as you output a full batch, also with outputting one part, basically meaning saving that part, the rotation will be remembered. Right.
Our following question is from Florian. Can parts be colored? For example, one color per customer to make them easier to identify in the build job?
Nice question. Thank you. We know it's available in some software. We actually didn't get the question yet. So as indicated, we really prioritize our to-dos, let's say, based on what our users want. This one wasn't in yet, so we will add that to the list, and we can definitely afterwards discuss when you want it, by when you would need it to actually have it. But it's a nice one to add to our to-do list.
Next up is, can small parts be grouped together in a sub-nesting, and can multiple nesting zones be defined?
Yes, thank you. That's definitely not a new one. We've heard that one before. Actually, it's also scheduled for the 3.5. It's in there, so that you have nesting zones. Currently, there are quite a few tricks to deal with it, and I wouldn't want to use the word workarounds, because it's really very easy to, for example, just resize your printer, put them in one side, and actually make that a zone, and then reset your printer, which is, as you saw, one click, to actually have certain parts in certain zones of your printer. So, but the real deal will be in by early May.
Can larger components with a tongue and groove or tenon joint be cut directly in AMIS, or does this preparation have to be done in a CAD program?
Same, no, not exactly the same, but almost same. That's exactly what we're doing the research on now, and that's what the colleagues are actually already starting to implement. So, cutting parts will definitely be in by early May. And what we're looking for now is the exact parameters, how you want it to be cut, meaning what kind of zigzag, what kind of distance between the parts that we have to leave, etc. So it's those details already that we're focusing on. And in May, the cutting the part will be indeed part of AMIS Pro. Right.
And a question from Ranjit, is it cloud-based? Is it a cloud-based application or a local drive installable?
It's a local drive installable. The options are expanding, possibilities are increasing, but for now it's just the local installable application indeed. Yes. Right. Wow, there were
Yeah, I think these
quick and
were
easy questions. So if there would be more difficult questions, they are welcome at any time. And I think that's actually about my next slide. Oh, if I can click it at least. The Sorry, what I want to say is, yes, indeed, at any time you can contact us. We will be glad to go in detail, to talk in detail about your questions. And I think that's also very important because we've seen a lot with a lot of our users that they have a different approach, a different way of working with it. And getting used to a new software always requires a bit of time, a bit of practicing. So we very gladly help you on that with that process. And an online meeting is definitely a good step to start with that. So please contact us. Of course, it's also possible to just start by yourself by downloading from our website a AMIS Pro version. But even after that, we'll be very glad to help you. We see that it really helps to get started. Adinda, anything more from your side?
We have one more question.
Oh, is it? Okay.
Can it recognize the tessellation present in the 3D model? Can we fix it? Can we fix it?
Um, I must say I don't immediately see what what is intended here. So I'm afraid I can't really answer that. It could perhaps it's something to go more in detail off the record, and we're near the end of our webinar. So please do contact me because I'm interested what you mean, but I can't immediately answer it. I'm sorry for that.
Yeah, we'll take that up maybe
Yeah,
after.
indeed. Sure.
Just to quickly recap, Chris, your very clear demo. What do we take away from this is actually that we really encourage you to think about your own strategy, start simple and then iterate. You can log strategically, if the mind density, you can use duplicate, rotate, etc. And you don't have to wait for the 100% for the nesting. For those interested, these are the upcoming dates that we'll be attending. So it would be lovely to see you all there. If you are interested in trying AMIS Pro, then you can download the free trial on our website. It's at amispro.be. And if you happen to have any questions, like Chris says, our team is always happy to help. Yeah, so thanks so much for following along, and yeah, let's stay in touch.
Thank you. Talk soon. Bye.